Hello everyone. Today I will be discussing a fascinating and vital tool in modern industry, the density meter. Density measurement is essential across a wide range of sectors, including pharmaceutical, petroleum, and food production. This presentation will explore what density meter are, their principle of operation, their type, and their application in various industries. As I written here about what is density meter. Density meter is a critical aspect of various industry from pharmaceutical to petroleum. In a short and layman word, we said that a density meter is an instrument designed to measure the density of liquid or gases. Simply put it quantify how much mass is contained in a given volume. Most density meter operate on advanced principles such as oscillation frequency or vibrating tube meter, which are based on relationship between density and vibration frequency. Mm. As right now I told about the definition of density meter. Here in presentation also written that a density meter is an instrument designed to measure density of liquid or gas. Principle is most density meter operate on principle of oscillation frequency or vibrating tube method. Now in the next slide I discussed about the importance of density meter. Density meter are very important. For example, if we want to know and understand about the purity of petrol, then we can easily understand by their density. We often see in petrol pump that there is a special column for density, means where it show the density of petrol. Here I written some of the few importance of density meter. First of all is quality control, second one is process control, and third one is product specification. If I talk about quality control, density measurement play a critical role in ensuring the quality of product in diverse industry like food, pharmaceutical, and chemicals. In process control, it provides essential information for monitoring the concentration, mixture, and formulation used in various production process. Density measures are crucial for maintaining consistency in product quality and ensuring compliance with regulatory standard. Now we talk about the basic operating principle. The advanced density meter are mainly operate on vibrating tube method. In this method, the density meter uses a tube or sensor that is oscillated at a particular frequency. The key idea is that the frequency of oscillation of tube or sensor changes based on the density of material inside it. The denser the material, the lower the oscillation of frequency. Means if material is more dense, then frequency is lower. Here in this picture, we clearly see that there is an execution circuit, there is an output electronic, and there is some object which is used to measure the frequency. There is a vibrating tube and there is a inlet. There is an inlet in which fluid is entering, and there is an outlet where fluid is just go out from this vibrating tube density meter. And the basic principle is frequency, means there is some standard frequency for a standard density they match it with, and they calculated it with on some API based like system in modern technology. A simple introduction into vibrating tube, and the frequency of vibration changes with sample density, as I mentioned right now. The meter measure this change to calculate density. Now, I talking about principle of resonance. Means when we want to match the frequency, there is some particular kind of frequency. In many density meter, the density operate near its resonant frequency, the frequency which it naturally vibrate. The resonance frequency will shift depending on the mass density of the fluid inside the tube. The basic operating of density meter involve measuring the changes in oscillation or vibration frequency of a sensor, usually a tube or U-tube, that is influenced by density of material being measured. Here we clearly see there is a peak, means there is a resonance, and at the period of resonance, that is the density of that particular fluid. Now I'm talking about the key component of density meter. While talking about the key component of density meter, we clearly see there is mainly five key component of density meter. First one is vibrating element. Second one is oscillator. Third one is electronic control unit. Fourth one is temperature sensor, and fifth one is sample chamber. If I talking about vibrating element, the part that vibrate when sample is introduced, that is called vibrating element. When we talking about oscillator, oscillator generate the frequency of vibration. Electronic control unit, as we see here, there is an electronic control unit. The function of electronic control unit to process the data and display the result. Temperature and sensor compensate for temperature variation as density is temperature dependent. Sample chamber where the liquid or gas is introduced for the measurement. Here, for example, there is a sample chamber. Here is an inlet and there is an outlet. That is a sample chamber. Now we're talking about the type of density meter. There are two or three type of density meter. For example, inline density meter, laboratory density meter, portable density meter. So clearly here we saw there are three type of density meter: inline, laboratory, and portable density meter. There is a Estonian company, Anton Far Product, which is mainly famous to sold a instrumental analytic device, and it sold a device. It sell a device like a benchtop density meter, compact density meter. I want to just give you a glimpse of their website. This is the Anton Par, that is Estonian company which sold the website, which actually sell the density meter, and this is the example of all type of density meter which they sell. If you go to any particular type of density meter, they also give their special features. They also give their special features. For example, if you talk about benchtop density meter, they give the features like this: 4-digit measurement in 20 second, ultra fast measurement mode, 200 plus conversion table for quicker result. Like that things, they explain about each type of density meter. Here in picture, what type of density meter we clearly see. uh, in our presentation we take a short glimpse of density meter DMA 4200M. Actually it is a density meter which is used in petroleum industry. As you know, density meter in petroleum industry there is a lot of product, and as I say that density is also one of the important parameter to check the purity of petroleum. Density meter for heavy petroleum samples are preheat the sample, transfer it using a heated syringe, and inject into the device. Now, while we're talking about key features, uh, we can operate it at minus 10 degrees Celsius to 200 degrees Celsius, preventing clogs with high heated syringe and a small sample volume with high accuracy. Now, while we compare this, we know that this is a 10 times faster measurement than the manual method, like picnometer. You see, it is faster. I actually take this referral from this stadium company. Whatever I said about that Anton per product. This is a referral which says something about this density meter, that is Anton 400M, 4200M DMA density meter, DMA 4200M. Here we written some features like fast result, easy filling, measure under pressure, immediate measurement, convenient operation, save your time, money, and solvent. Here also we talk about quality control. Means it is very helpful. Density measure provided by DMU 4200 are used in research also. Means this density meter is also used in research for finding determination the equation of a state, calculation and configuration of production process, pressure, volume, temperature analysis of crude oil. Like these things we use. Density measurement of petroleum sample by DMA 4200M from upstream to downstream, on incoming crude oil, on intermediate and process sample to give a quick feedback on the refining process, quality control of LPG and heavy samples for converting volume to mass when tracking asphalt and bitumen. Now we're talking about the calibration of density meter. As I mentioned in DMA 4200 meter, we also use some mathematical equation. Right now here I am not able to write that mathematical equation, but in that mathematical equation there is a some constant. We calibration, we importance to calibration. We just write three short terms like importance of calibration. Calibration is essential for ensuring the accuracy of density measurement. While talking about a method, calibration is typically done using a standard liquid with known density or by comparing measurement against reference material like water or ethanol. While talking about regular recalibration is crucial to maintain optimal performance and ensure the continued accuracy of the density meter. Now, while talking about application of density meter is used in chemical industry, food industry, petroleum industry, pharmaceutical industry. As I discussed earlier, means into part also that it is used. Advantage of using density meter is it have high accuracy. Density meter provide precise and reliable measurement, minimizing error and ensuring accurate data. Second, real-time result. Inline density meter offer real-time density data, allowing for immediate monitoring and adjustment in production process. For example, water flowing in a pipe have different velocity, maybe different density due to change in temperature, but there are some density meter which give the real time result that is very helpful in industrial level. Now third one is non-destructive. Most density meter method are non-destructive, meaning they do not alter or damage the sample. Easy integration. Density meter can be seamlessly integrated into automated production system for continuous monitoring and control. Now, when we talk about conclusion, density meter are versatile instrument that offer precise measurement and play a crucial role in various industries, ensuring quality control, process monitoring, and product consistency. The accurate and reliable data provided by density meter contribute significantly to various applications from research and development to production and environment monitoring. Now, thank you. Thanks.